Hi guys, this video describes the stack abstract data type. This describes the concept of a stack, the terminology involved, and the major operations of a stack. Later videos will explain how we implement stacks. So stack is an abstract data type. It's this abstract idea for how a data structure could work. And the basic idea is that it organizes elements into LIFO order, as it's called, LIFO. LIFO stands for last in, first out. That means that elements go in and out, and when an element comes out, it's the last one that went in, the most recent one in time. It's inspired by something like a stack of plates. Here's a picture of plates from my cupboard, and the way that stacks of plates work is that it's very easy to look at the top plate, add another plate on top, or remove the top plate. That's convenient and fast. What is not convenient and fast is adding or removing plates at any other location. If I decided I wanted to pull out the bottom plate here, it's going to be a hassle. It's going to be time consuming or inefficient in computer speak. Same thing with any other operation anywhere except the top. So easy to add and remove to the top, not so easy or maybe even impossible to add or remove at any other spot. So there are three major operations that we define on a stack, and these are inspired by one of these cafeteria dish dispensers. If you've ever gone to a buffet, you might be familiar with this kind of contraption, and the way it works is that it holds a stack of plates warm for you, and you can place one on top, and that kind of pushes all of the plates down into this spring-loaded chamber, or when a client pulls a plate off the top, then they all kind of shuffle up a little bit automatically because it's on a spring. So the names of the operations we have on a stack are top. Top returns the element at the top. Whatever the top plate or data element in the data structure is, we can access that top element. Push, X, inserts X at the top. So if I want to place a new element in the stack, I push it is the word. And you can imagine in the real world, if we were working with this cafeteria setup, we would push a plate physically down to make it go lower. So that X that I pushed becomes the new top. So if I push X at the top, it's now on the top of the stack. So if I use the top operation to look at the top of the stack, I'm going to get that same X right now. So when we push X, the other elements move away from the top. If you visualize placing a plate on the top of the stack here, the plate that's currently at the top is now in second place, and the plate that used to be in second place is now in third place. So they all kind of shuffle down away from the top when that happens. Finally, the third major operation is pop. Pop removes the top element. So if I wanted to grab a plate, that's called popping. If I pop the top element comes out and the other elements move toward the top. If I peel off this top plate here, the one that's currently in second place is now at the top. Here's how we usually sketch a stack. So it's a column of elements kind of in a bucket. I've got this line here. This represents that kind of bucket or that tube that cafeteria plate dispenser had. So note that it has an open top here to show what side the top is. The top element of the stack is at the top of the column, the first row. So in this sketch, 38 is at the top of the stack, and then -1 is in second place, 8 is in third place, 31, and so forth. The top is kind of implicit. We've been strict about labeling the head of linked lists and things like that, but in the case of stacks, it's pretty clear that when you draw this kind of U bucket with an open top, that's where the top is. So we don't usually write out the word top or anything like that. It's just implicit that the first row number is the top element. Here's an example of running these operations, push, pop, and top. So first I create my empty stack. It has nothing in it, so I've just got my bucket here. Let's say I push 6. Now there's one element in the stack, 6. 6 is the top, it's the only element. Push 5. So now 5 is at the top of the stack. We pushed 6 down. So 6 is in second place, 5 is at the top. Push 7. So now 7 takes the top spot. 5 is in second place because it was the most recently pushed element before the 7, and then 6 was the most recent element before the 5. This is that LIFO, L-I-F-O, last in, first out phenomenon, where the most recently pushed element, the 7, would be the first one to come out if I were to pop at this point. So let's do that. I pop the 7, it goes away, and the 5 shuffles back up into the top position. If I push a 1, then the 1 is now on top of the 5. Last in, first out again. push a 4, now the 4 is at the top, pop the 4 back out, last in first out happens. Okay, so that's how the stack works.